Welcome to Tech Teach.
Previously, we have seen the sine waves is example of analog signal. So, but the signals or the data can be represented in terms of digital signals also. So, these digital signals will be representing a high value or low value. So, for example, if one can be encoded as a positive voltage, then and zero as the zero voltage, then it will be behaving like a digital signal. So, we are having a digital signal can have more than two levels. So if a signal is here, it is saying like in case of digital signal, so suppose we want to represent one. So one is given by like suppose 5 volt and zero is given by 0 volt. So if it is 5 volt, it will be given by like signal 1. If it is 0 volt, it will be given like signal 0. And this is time and this is the value. So this is basically the digital signal. Okay. So this is the digital signal that is having two levels. One is 0, another one is 1. So this is level 1, level 2. Two levels are only there. But there can be a signal that can have more than two levels. If more than two levels are there, then for an example, it will be like more than two levels, like one level, two level. Then it is going to be here. This is one level and this is another level. So like this. So level 1, 2, this is 3 and level 4. So 4 levels are there. So in case of like two levels, if only two levels are there, one bit is required, either 0 or 1. If 4 levels are there, then we will be requiring 2 bits to represent 4 levels. Okay, so this is going to say like if more than 2 levels are possible, in this case, we can send more than 1 bit for each level. Okay, so if 4 levels are there, so then we need to encode each level with 2 bits. So here two signals, digital signals are given, one with 2 signal levels and other with 4 signal level. So this 2 signal level is like level 1 is 0, level 2 is some value. Okay, so some value is there, level 2. So higher level will be represented by 1, lower level will be represented by 0. So it is 1 0 1 1 0 0 0 1. This is how the signals are basically represented. So one thing it is given like, so suppose starting with 0 to 1 second. So this is the 1 second. But here it is written like 1 second. So it is the 1 second duration. Into 1 second, how many bits are represented? So 1, 2, 3, 4, 5, 6, 7, 8. So 8 bits sent in 1 second. Its meaning is bit rate is 8 bits per second. So this bit rate is given as the number of bits that is being sent into 1 second. So bit rate, so we can write here, bit rate will be equals to like number of bits sent in 1 second. That will be given by the bit rate. So in this case, the bit rate is 8. That is 8 bits per second. So its unit for bit rate will be bits per second basically. The second type of signal is the digital signal, but it is having 4 levels. So level like this one is the level 1, then level 2, this one, level 3 and level 4. So if 4 levels are there, then there is a requirement of 2 bits for each level. So if 4 levels are there, so the number of bits required to represent n number of levels is given by the formula like log n to the base 2. So here n is the number of levels. If n is the number of levels, the number of bits required will be given by log n to the base 2. So if 4 levels are there, so we will be writing here 4. So for 4 levels, log 4 to the base 2 will be given by 2. So 2 bits will be represented. So each level will be having 2 bits. So in 1 second, how many levels are there? We can just see. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 levels are there. So for representing 8 levels, 8 to the 16. So 16 bits will be required. So you have 16 bits sent in 1 second. So bit rate is 16 bits per second. Okay, so it is 16 bit per second. So time and frequency domain of a periodic and non-periodic digital signals. So previously we have seen analog signals in time domain and frequency domain. Similarly, we can get it into digital signals into time and frequency domain. So in time domain, digital signals will be having, likewise, we have just seen with some magnitude, some highest level and lowest level. So this is level 1, this is level 2. So 2-level system is there. Okay, and because it is periodic, so this one is the periodic digital signal. So if this periodic digital signal, its frequency domain conversion, we will just see its frequency domain conversion. So suppose this is the frequency. So here this was the one time period. So frequency is given by 1 by t. So in frequency domain, at f frequency, it will be having a magnitude. Then it is going to add 2f. Then there will be having a magnitude. Then it is going to have 5f. By 2f, it will be increasing, and its magnitudes is basically going to decrease, keep on decreasing. Okay, so this is how they represented. It will be going up to infinite frequency. It is going up to infinite frequency, but its value will not be 0. Okay, but it will keep on decreasing. So this is how there will be there a periodic and discrete. So periodic and discrete is there. If periodic is there, then it will be discrete in. So in frequency domain, it will be, because whenever a periodic analog signal was there, it was discrete. In frequency, it was discrete. Similar to that, in digital signal is there. If it is periodic, it will be discrete, but for different frequencies it will be there. If here, if it is non-periodic, if a digital signal is there but it is not periodic, so if it is non-periodic, in here it will be a continuous one. It is similar to the analog signal itself. So analog signal were periodic means non-periodic, then its frequency domain was the continuous signal. So similar is the case in case of digital signal also.